All right, good morning. And this is our first attempt here at doing a video. We're going to give it a shot here. This is just a test run, but we're going to see how it works. Hope you guys are all doing well today. I'm going to have to get used to the fact that I'm looking at the camera and not looking at myself. I notice myself looking back at the screen. So we're going to go ahead and do our first lesson for the algebra class here. Remember, all these lessons are optional. You don't have to do them. This is just me helping prepare you as best I can for what's coming next. These are the standards and the topics that we didn't get to prior to spring break. So again, we're going to upload things. I'm going to send up YouTube videos for you to watch. I'm going to upload documents to Synergy and probably Office 365. So again, you guys do what you want. If you've got questions, if you want to send things in, send them in to me and I'll help you as best I can as we move forward onto this new platform. Miss you guys. Wish I was at school right now. But we're going to have to make the best of a situation, and hopefully we'll look back at this time as being something that just made us stronger and made us better at everything that we're doing. So we're going to go ahead and turn on some of the other things right now. It's going to get a little weird for a moment here. We're going to turn on the display, which is going to put things in the background there. We're going to shrink me into the corner, and we're going to go over to the document camera first. So our big idea today is going to be simplifying radicals. What I would do right now is just kind of follow along under the document camera, and then we'll talk about things that are a little bit more intense. So right now, as far as a radical is concerned, we know about the square root of 36. And we know that we can take the square root of 36, and the square root of 36 equals 6. All right, 6 times 6 equals 36. If we take that a step further, and we look at something like the square root of negative 36, if we ask ourselves what number times itself equals negative 36, we're thinking negative 6 times negative 6. That doesn't work because negative 6 times negative 6 makes 36. When we start looking at taking the square root of a negative number, we realize that we can't do that. You can't take the square root of a negative number. And so basically what we would have for right now is a no solution. When you get to higher level stuff, Algebra 2, they're going to talk about imaginary numbers. The square root of a negative number is going to be an imaginary number. Where we need to now go is we need to consider what happens if I want to take the square root of a number like 24. Square root of 24 is not a perfect square, so you can't do it. So what do? You use the calculator. And you'd say the square root of 24 equals, and we'll put that underneath the camera there. Square root of 24 is a decimal. It's an irrational number, 4.898979486, and that decimal just keeps on going on and on forever. We need to have a way that we can work with this, and this is where simplifying radicals come into play. We're going to have decimal answers, and we're going to have answers that are given in radical form. We're going to talk today about how to simplify radicals. Okay. So we're going to shift over here to our flip chart, and we're going to look at what it is to simplify radicals. Well, there's a couple rules for simplifying radicals. This is a PDF that's already been uploaded, by the way. You can copy this in your notebook if you want, or you can just find this document and look through it. The first rule is no perfect squares are left inside the radical. Now this is going to be our main point of focus for today, is how do we get radicals out of, or excuse me, how do we get perfect squares out of the radical. The second two features are going to be features that become a lot more intense as we go further into this chapter. No fractions in a radical. That's going to be easily addressed today. No radical in the denominator. Now that is going to take care of itself today. Later in this chapter we'll address how are we going to do that. The first step is the key. No perfect squares left inside the radical. For those of you with strong multiplication skills, this is going to be pretty easy to do. For those of you whose skills are a little bit weaker, it's going to take you a little bit longer to simplify a radical. You need to factor the number to find perfect squares or matching factors. If you can't find a perfect square, or you can't see the perfect square, then you're going to need to factor tree all the way down to find matching factors. Two numbers are freed as one. So once we find matching factors, they free themselves. If you want to pause right now to copy this down, go ahead and pause it right now to copy this down. And then you can go ahead and meet me back, because I'm going to go back to the dot cam now. If I go back to the dot cam and I go back to this problem that we had, which is the square root of 24, it's not a perfect square. Well, what we're going to do is we're going to factor tree this. So this is something you would have done in 5th or 6th grade. So we're going to take 24 and we're going to factor tree that into the square root of 4 and the square root of 6. Now you could have picked other factors, and I'll show you what happens if we had picked 3 and 8 or 2 and 12 or whatever else you were thinking of. But if I look at this here, I have a perfect square. 4 is a perfect square. And the square root of 4 is 2. So 2 is now free from the radical because I took the square root of 4. 6 could factor down further into 2 and 3. There aren't any perfect squares, so that doesn't help me. So radical 6 cannot go any further. So it's going to go right next to the 2 that freed itself. So the simplified version for radical 24 is 2 radical 6. Now let's say we had done different factors. So let's go 2 and 12. No perfect squares. Let's go further with 2 and 6. And then let's take the 2 down into 2 and 3. So we're going to factor tree all the way down. No perfect squares. But if you remember, factor out the perfect squares or find matching factors. Two numbers are freed as one, so it's like they're in jail. So all of these numbers at the end of the branch, the 2, the 2, the 2, and the 3, are all at the end of a branch. They're still all stuck in radical jail. But these two factors can partner up. They partner up. One breaks free of jail, and the other dies. So this one broke free, this one died. They partnered up, they teamed up, but only one of them gets to break free of jail out here, and the other one dies. These two cannot partner up, so I multiply them back together, and 2 times 3 equals 6. And they stay on the inside, and you'll notice the same answer, but we just got there in 2 different ways. So let's take a look at another example. Let's take a number here that's maybe a little bit bigger. Let's take the square root of 80. So the first job is to find factors of 80. And whatever comes to mind is going to be different for each person. For me, I think of 8 and 10. Now 8 and 10, neither one of those is a perfect square. So I'm going to break it down further into 4 and 2. And I'm going to break the 10 down into 5 and 2. Now if I look right now, there are a couple things that jump out at me. The first is 4 is a perfect square. Well, I'm going to take the square root of 4. And the square root of 4 is 2. So I have taken the square root of 4 and I've put a 2 that is now free of the radical. I also notice that I have a pair of 2's. So they partner up. One breaks free. So here's another 2 that broke free, and then this one dies. And then I have the square root of 5 here left on the inside. So I had a square root of 4, which equaled 2. And I had a pair of 2's that partnered up. One broke free, and the other died. Well, let's take the numbers that broke free and multiply them back together, and I get 4 radical 5. Well, for those of you who are good at multiplication, let's go back to the radical 80. If I look at that radical 80, another way I could have factored this would have been 16 times 5. Well, the square root of 16 is 4, and I have the square root of 5 left on the inside. So you'll see, same answer. This is why I said if you're good at multiplication, some of this stuff is going to get pretty easy. Now, let's go ahead and take a look at the second step that could happen. No fractions in a radical. Well, if I go into the idea of no fractions in a radical, let's take a look at an example of what that would be. So if I come back over here, and let's zoom in a little bit here. If I look at this fraction that I have here, I have 3/4 inside the radical. Well, in order to take care of this fraction that's in the radical, I am going to simply take it and split it up into a radical 3 on the top and a radical 4 on the bottom. So I am simply going to take the fraction that was on the inside and I'm going to split it up into a fraction that has a radical on top and bottom. Well, the good news about this is that the bottom of this fraction, the square root of 4, is 2. And on the top I have the square root of 3. And if I go back to my final rule, no radical in the denominator, fortunately, the square root of 4 took care of that for me. And that's going to be the case for every problem tonight, is that the denominators should be perfect squares. We'll address later on what to do if it's not a perfect square. So let's take another example of what we could potentially do. What if I had a radical with the fraction 6/3 in it? Well, what I want to look first of all is, what can I do with all fractions? Well, all fractions can, you got it, reduce. So this 6/3 simply reduces to radical 2, and I have taken care of what I needed to take care of. Let's take a look at one final example of what we could potentially do with radicals and fractions. Let's take the number 10 outside of the radical. And then I'm going to put a fraction of 11 over 36. This 10 is being multiplied by whatever is this radical. So as I work my way through this, I'm going to always have a 10 that's going to be multiplied in front of whatever happens. And we're going to remember later on that I can take any integer and I can make it a fraction by putting 1 underneath it. So let's start first of all by splitting up the fraction that's inside the radical. So I have taken the 11 and the 36 and I've split up that fraction. Now, if I look in the bottom, yay, good news, radical 36 is a perfect square. So let's go ahead and do that. Let's put the 10 times in front, radical 11 over 6. Well, let's put the 10 over 1, because I need to work with these fractions. If we look, the 10 and the 6 are both out of the radical, and they are in fractions that are being multiplied. Well, this allows me to cross-reduce the 10 and the 6. Well, 10 and 6 can both be reduced by 2. So this 10 becomes a 5, and this 6 becomes a 3. So the 5 multiplies the radical 11, which stays in the radical. And in the bottom, I have 1 times 3, so 3. Remember, all fractions can reduce. All fractions need to reduce as we do this. Now, I want you to go ahead and take out your homework assignment. Pull out your homework assignment. I'm going to show it to you, so if you haven't printed it out yet, that's fine. We can do so afterwards. All right, we're going to come back over here, and we're going to talk about our notes. All right, that way I can hide the document camera as I prep for our assignment here. And I want to remind you of the basics up here at the beginning. Factor numbers to find perfect squares, or matching factors that can free themselves as 1. That's going to be the key as we go through and do these problems. Okay, so what I want us to do here, and I want us to go ahead and look at our 9-2, practice A, and we're going to start with number 9. So let's go back to our document camera here, and let's take a look at our number 9. So we're going to say, okay, this is assignment 9.2a, and we're going to start here and we're going to do number 9 together. So number 9 is the square root of 20. Well, we've already looked at the square root of 20 as one of our examples. So we're going to break down the square root of 20 into 4 and 5. And the square root of 4, I can take the square root of 4. The square root of 4 is going to be 2. So this final answer equals 2 radical 5. Okay, let's take a look at our second one. Let's take a look at number 10. We have the square root of 12. Now, it depends what you break it up into. I'm going to break it up into the square root of 4 and the square root of 3. Let's take the square root of 4, which is 2. So this equals 2 radical 3. If we go through and look at the rest of these examples, they're all pretty much the same until you get to number 16. Now, number 16 has 2 radicals that are being multiplied. I could multiply these 2 back together because they're both in a radical, and I could get 12. But that doesn't help me a whole lot because I'm still going to have to break it down, and what do we see right here? We see the square root of 4. Okay. Now, the second section for our homework is going to be what we talked about with our fractions. All right, so if we remember with our fractions, we're going to go ahead to number 17 here. We're going to have the square root of 3/4, which we already did as an example. So that's going to be the square root of 3 over the square root of 4. I can take the square root of 4, so this becomes radical 3 over 2. Let's look at a second example. Let's look at number 18. The square root of 9 over 16. Now the square root of 9 over 16, we're going to split up into the square root of 9 over the square root of 16. Well, if we look very closely at both of those square roots, I can square root both of those. So on the top, the square root of 9 equals 3. And on the bottom, the square root of 16 equals 4. So that simplifies down to 3/4. Now let's take a look at number 21. If I look at an example like number 21, say, okay, how am I going to handle that number in front? Well, we don't have to worry too much, because if you look at what happens inside, remember from our example, 6 over 3 can reduce down. So I get a 3 on the outside and a 2 on the inside. Let's move this out of the way here. But if we look at number 22, this is going to require us to put several pieces back together. So let's split up the top and the bottom. Remember, you've got a 2 in front, radical 7 over radical 9. I can take the square root of 9. The square root of 9 is 3. And remember, this 2 is over 1. So I'm going to multiply the top, which is 2, times radical 7. Now the 2 is out of the radical. The 7 is in the radical. So they do not get to multiply and make 14. It's simply going to make 2 radical 7. If you look at the very last portion to our homework here, you're going to see that you have numbers that are in radicals on top and bottom. We can handle these in two different ways. We could simplify each one. So for example, this one here, I can take the square root and I can get 8 over 6 and then reduce that down to 4/3. The other option we have is that because both the top and the bottom, so if we look at number 26, both of those numbers are in the radical. If a number is in a radical on the top and the bottom, I can reduce. If one is in the radical and one is not, I cannot do anything with that. So if I go back to this 80 and this 4, it can reduce. And the 4 reduces away the 80, and this is then radical 20 because the 4 cancels out. And now let's simplify radical 20, which if we remember that from number 9 on homework, we have 2 radical 5. One of the things I want to stress to you is remember problems you've already done. You've taken the radical or the square roots of lots of numbers, and they're going to appear again throughout this entire worksheet. So keep that in mind as you go through. Okay. What I want you to do is I want you to go through and practice 9.2a, and that assignment for 9.2a is going to be problems 9 to 32, and then 9.2b, which is going to be the back side of homework. Let's see if we can find that 9.2b. And for 9.2b, I want you guys to do 9 to 36. Now the one thing I will tell you about this is that when you get down to these problems here at the end, these problems are going to be a lot more complex and are going to be more difficult. I anticipate you having some questions on that. When you get those questions, feel free to send them to me, and what I will do is I will go ahead and try and send you a response to it. Remember, tomorrow we're going to have a Zoom session. So for those of you who need to log into Zoom and ask me questions, I've got office hours tomorrow, and those office hours are going to be at 9 a.m. for all algebra students. All right? So do your best to work your way through this. I know this is uncharted territory, working at home. If you have any suggestions for me moving forward with these videos, please tell me what you've got, because in all honesty, this is new to me as is new to you. I'm doing the best I can. All right. You guys take care, and I'll talk to you tomorrow.